Okay, for people joining this live stream, we are talking about synthetic geometry in Wolfram Language, getting ready for the initial release of this in the next version of Wolfram Language. So, the function currently known as triangle data.
Right, which I'm going to be very insistent can't be called triangle data, but we can talk about what it is first.
Okay, so what is this doing? Median C1, C2. What is this doing? This is making a line from, I don't even know what on earth this is.
Okay, so the first argument specifies a triangle can either be a list, and currently it only works in 2D. It's either a list of points or, triangle or polygon or regular polygon or something, but it specifies a triangle somehow. The second argument is some sort of specification for what you want returned. So for instance, in this first one, the median with specification C1, C2, which has to be a vertex of the triangle, is the line segment from that vertex to the midpoint of the opposite side of the triangle.
Okay, so wait a minute. This is a new construct. So we didn't have this construct before.
Correct.
So where does it come from?
Basically, so inside of synthetic geometry, there's a whole bunch of semi-obscure things that had to do with triangles. So we decided rather than have 5,000 different heads, we'd have one triangle something head.
Okay, let me just get back up to speed on what the the parts of this that are uncontroversial, okay? Because this is a new thing which I don't, have to try to understand. Right, let's pull up the guide page and let's just start off talking about the things that we think are, not so controversial. Fair?
Yeah.
So you say the guide page is, what is it called?
syntheticgeometry.nd.
Synthetic. Did I spell that wrong? Oh no, there we go. Okay. All right. So let me just try doing, just because I like doing this, some very basic things. Okay. Just to set some context here. Okay. So I can say geometric scene. Is that right?
Right.
For example, yes. ABCD, and then I would say something like. So let me just try to understand what I can type in here. So, by the way, okay, what does polygon angle? Does polygon angle work in like an ordinary polygon?
Yes.
Yes, and we should probably discuss that during geometry meeting on here.
Okay. What does planar angle do? Okay, that's interesting.
So planar angle is specifically the 2D thing that, always gives you, well, you can ask for it, but, the proper angle, the clockwise angle, the counterclockwise angle, etc.
Okay, so give me an example of some minimal thing that I can type in here with like a triangle and a circle or something.
Okay, so it'll be a list.
Yeah.
And we can do, say, circle through list ABCD.
Okay.
Close, comma, triangle of list ABC. Close list. We can do, I guess.
Let me do one more thing here. What can we do with the D?
Well, so actually, let's. So I'll go back.
Let's
to
put a triangle here. I want to do this. I want to make this. I want to do BCD. There is my second triangle. Okay.
So you're going to have to Do find geometric scene instance to draw it.
Yep, find geometric.
And also just a heads up, the drawing code is a little fragile right now since we've been adding a bunch of new stuff, but this should still work.
Very cool. Okay, so I've got a couple of questions about this.
Yeah.
Okay. So the styling of so first of all, I don't like the fact that this has somehow managed to not be in the center of the whatchamajig here of the bounding rectangle. I don't know why that is. It looks like a just simple bug.
Yeah, there are many more problems for similar problems.
Okay, no matter. But okay, second issue, the styling of this. Has this gone through graphic design at this point?
No, this is from Tim. So it's not our own role, but it's also not graphics design either.
Right.
Okay. Is Tim in this meeting?
No.
I think it looks quite nice. I mean, I'm not. I just would like to make sure that we've had a proper review of that graphic design.
Yeah. And we will probably not for the first version be able to have plot themes.
Right. But style works.
Okay. Okay. Now, what's happening here, I am not convinced about. That is the fact that it's different every time.
Well, that's if you want it to be the same every time, you can do.
That's like random real. It shouldn't give every time.
Right. That's a feat. It's supposed to be different every time.
I understand that, but it doesn't say random anywhere. If we're going to do that, I think we should have random in the name of this function.
Well, it's like find instance.
But which isn't random. Find instance is not random. Find instance is completely deterministic.
No, it's not. It takes a random seeding option.
But the random seeding option is by default set to 1, 2, 3, 4, isn't it?
Probably. I don't remember exactly.
Because that's what I think we should do here. I think we should make this. I really think it's a mistake to have this not be deterministic. I mean, the fact that it has. Get what I'm saying? I mean, so this takes a random seeding option probably as well, right?
Yeah.
Correct.
So I claim this should be the default.
The problem is
you confuse people. I feel like if they don't get a good one, they don't know what to do.
Right. It's impossible to we do the best we can filtering out the kind of degenerate scenes, but some of them are going to filter through, and people are going to want to just try it again and hope for a better picture.
Shouldn't you then have a third argument where you can request a certain number like 2, 3, 4?
That we do have that.
I am wondering whether it should be called random scene instance. Because I think it will be easier for people to understand that.
But I feel like we should probably keep the word geometric if we do it. We might want scene later for something else.
Okay.
That's a really long title, though. And I don't know, geometric and scene are a little bit redundant, at least.
Well, okay, but with the question about, I strongly believe that we should have the word random in this name.
I have to agree with Steve.
I'm sorry, Michael, you say you do or do not agree?
I do. You're right, kind of. Like
it's too weird to do this every time, and I mean, for elementary students and so on, it's just too weird to get a different result every time.
With this name, but the feature itself, I think, is the design.
Oh, the feature is great. The feature, there's no problem with the feature.
Right.
But I would point out that random functions don't take a random seeding option. Right, you can block random around them or seed random around them.
I understand. By the way, the obvious thing to do is just, is it, boy, should this be random geometric scene? No, that's wrong. What's that?
No, the scene itself is not random.
Yes, quite. Well, okay, provisionally this name, but I'm not, I agree it's a bit long and ponderous, and if we could shorten it, it would be great. I mean,
what about random instant? And random instant is a mega function that later on eats other things.
I think that's a good idea.
I was just thinking that because like we already have geometric scene.
Yes, I think that's a good idea, Michael, and I think that's a good idea for. I can imagine that being useful for some machine learning things for example, learned distribution. Yeah, I like the idea. We should propagate this. Let Etienne know about this idea of having a random instance function.
Okay.
Now, to Itai's point, yes, it's unfortunate that there's a random seeding. I mean, arguably, we could put random seeding into random word, random entity, et cetera, et cetera, et cetera. All right. Anyway, let's continue with this review. I think we do need to talk about the random seeding thing. I would argue that we should put it into the other random functions.
No, we had that whole conversation, right? I mean, it works by, I mean, are you suggesting you should take, that random integer should take a random?
It is what I'm suggesting, but maybe it's absurd.
Yeah, it's not a good idea, but let's defer the conversation.
Doesn't matter. But, Sandra on our live stream is making an interesting point, which is, is there a way you could get the seed if you just found a wonderful instance? Is there any way to get the seed? And the answer is we don't have any way to get the seed right now. I could imagine some accessor getting the seed, but I just don't think. Yeah, I just don't.
Now, we could, in principle, bake the seed into some method like options, so that find options would return it on the evaluated scene.
Yes. Well, that's interesting, or a sub-value of the generated scene.
Right.
But it must, of course, be somewhere inside in the full form.
Yeah, I don't think that's a terrible idea. I mean, it seems, but it's not totally obvious how you give the seed and so on. Okay, listen, I really like random instance I think that's a really much better name for this. Okay, let's keep going here. So if by the way, if I just for fun add another, just to see whether I okay, so let's say if I say circle BAD.
Well, so that's you'll need circle through, or you can actually do circle the right. So that will internally it'll recognize that these should recognize these are the same circles, and just kind of ignore it.
Oh, that was no fun. I wanted to do something much wilder than that.
Okay, you could say in the first argument make a point E with explicit coordinates.
Actually, what I want to do is I want to have one of these points be the bisector of a line. How do I get the midpoint of the line AB?
Say midpoint of AB.
Midpoint A,
B.
no lists.
No lists.
I don't think. Yeah, right. I forget whether. So midpoint is.
It's further down in the agenda.
You're right. I think I've implemented it in here. See, this is why you want the randomness, because sometimes it's degenerate.
That was very degenerate.
Yeah.
What is your degeneracy checking right now?
So it's.
I mean, and how many instances do you typically generate?
It depends on the scene. So currently there's isn't really degeneracy checking per se. So there's a call to find minimum. There are certain add-ins for the objective function to hopefully discourage degeneracy. But then the final check at the end is the constraints are met and the objective function is at most 0.01 or something.
Okay, but in practice, why are we seeing such degenerate cases showing up?
It's the first thing that find minimum.
In some sense, by the end of the day, I think it's a reflection of the numerical method for finding it.
Right. It's
okay, but so we should figure out how to do it a little better, or we should generate 3 of them and pick the best of the 3 or something.
right. Well, I think
this is our, we only get to put 1 foot forward here.
Right. I think probably the way to go is add in some more things about pairs of points have to be a minimum distance apart, and that will make certain scenes impossible. But we'll just have to have the users at their own risk put in concrete.
No, if you do 3 cases, look, do 3 cases and say pick the best of 3.
Right, but Stephen, I think also part of one issue here, right, is that you've selected, the midpoint of 2 consecutive points, right? So,
am I doing something stupid? Yeah, I'm doing something stupid, right? So that's always a bad thing. Okay, that's more impressive. That's pretty cool, actually. Yeah. Okay, so I did something dumb. Is basically the point.
Right.
Which forced it to be degenerate.
Right. Either degenerate or, really, really big differences in the size of the 2 circles, which is why you ended up with something that looked like that.
Yes. Well, okay, fair enough. Okay, I've got another comment here, which is about the design here.
Yes, we know this one. Yes, we just discussed it an hour ago.
These have to change in size.
Yeah.
Okay, no problem. Okay, all right. Let's get down to. I really like random instance, by the way. This is a real improvement. It really helps. Okay, let's keep going here. So, so we got all of these cool functions. Perpendicular, but these are really cool. Okay, fine. All right, I get it. Okay, now what do you want to do? What is triangle data?
So triangle data is basically mushing a bunch of triangle functions all under one head, and the outputs can be different. Some of them are geometric objects, some of them are scalars. So
all right, so I doubt that that's the best of ideas. Okay, so to put all of those together, I mean, look, triangles are a big thing in the world. Having 5 triangle functions is not the end of the world, so to speak. Having 100 triangle functions is ridiculous. Okay.
Well, I think you were closer to 100 than to 5 is the point.
Right, but so what I'm possibly suggesting is taking these buckets here and making each of these a function, possibly. So, for example, this one here, just as a possibility, triangle center. And then the default center is the centroid.
Right.
But then there's a lot of other exotic centers.
Also, some of those aren't really centers.
What are they?
Like foot.
Okay.
It's the foot of an altitude.
Right.
Okay, well then again, maybe we break those apart. I mean, maybe there's what I'm suggesting is that what we aim for is a collection of like these, for example, the centroid, the circumcenter, the orthocenter, blah blah blah. Those are all conceptually the center of the triangle. They have different specific ways of being the center, but conceptually they're all in the bucket of center of a triangle.
Right. The only knock I would have against this, so currently triangle data, given a triangle, you're only allowed to return one thing from it. But if we wanted to allow returning, say, the in center and the in circle.
Why would we want to do that? Why not just have 2 functions there?
Okay.
I mean, I don't see the point of return. Why would we want to return those 2 things together? Is there any?
Well, in terms of graphics, if you wanted to display the circle and its center and several things about the same triangle at once. Currently, we can't do that, but theoretically, we could have.
Well, absolutely. But then why don't we have a list of things here? Triangle, center, blah, triangle. I mean, the listability is not a huge problem here. The cross listability of let's not worry about that. Let's keep going in this direction for a second. So I'm gonna let's break apart these things just so that we have a I just want to. I'm just breaking these apart just so that we can type in between them. Okay. So now, okay. So first of all, these circles. Now you've already got. I see. Circumcircle. Okay. So circumcircle takes a triangle.
Right. It's the same as circumsphere, but it returns a circle instead of a sphere.
Well, why are you calling it I mean, so, okay, first of all, so the first argument here, I claim, of all these functions should be either the naked points or the triangle object. Do you agree?
Yeah,
which is currently the case, yes.
Okay, fine. All right, okay. So I'm going to suggest, I mean, again, let's take a look at this idea. Okay, so triangle circle, it would default to the circumcircle. And, okay, so let's keep going here. So this one, I claim, should be called, I claim this triangle measure, I would say, triangle measure. Potentially. And then I don't know what it probably defaults to the area. Because that would be the obvious triangle measure.
I think we should avoid measure. I think it should be measurement or something like that.
Yeah, I would go with measurement.
Okay. I don't particularly like measurement. Is there something better? I agree measure may not be right because like the height.
Triangle value?
Or triangle property.
Well, but these aren't...
Characteristic?
Yeah.
What's that?
Characteristic.
It's not really a characteristic because property would be things like, is it an... okay, where do we get to ask, is it an acute or an obtuse, or is it a scalene, is it a... Gosh, it's so long since I even said that word. Is it a scalene triangle? Do we have any function that answers, is it a scalene triangle?
Not yet. That will come together with asking for, like we wanted in the second round, a dedicated function for asking for numerical values about objects.
Right. So inside of geometric scene, we have something called geometric assertion, which is kind of the way of asserting that certain properties of geometric objects, but we don't currently have a geometric assertion of triangle, comma, scalene.
Right, but that's an assertion. So there's also the point of being able to say, okay, so you've got a geometric assertion of object, comma, property.
Right.
Right? Okay, so what we also want to get is we could imagine a geometric value possibly of object, comma, property, which tries to compute it. Like, is it a scalar triangle, scalene triangle? I'm not sure that's right, but that would...
So the property would be a string, so it would be a scalene Q, or what would be the name?
Okay, so here's it would be a triangle here. This would be scalene. Yeah, it would basically be scalene Q.
Okay.
It might just be scalene, but down here, okay.
But it doesn't have to be a Q1.
No, it does not have to be a Q1. Is what I'm proposing. Like that could say area, for example.
So geometric value would be like a super function of triangle data.
That's what
geometric value would be a super function that would apply to all of Charles's geometry, not just synthetic one.
Yeah, so maybe two super, but I mean triangle value. Then you're suggesting here. What other possibilities do we have?
We had a list of possible names for triangle.
Yeah, at the bottom there's the possible triangle property, triangle construct, triangle construction, triangle feature, triangle detail. Triangle.
Yeah, I see it.
But those are trying to encompass the whole thing.
Yeah, which I think is a mistake. Okay, let's look at these other ones here.
So this would be probably triangle Cevian.
What is a Cevian? I've never heard of that. What is it?
A Cevian is a line segment from the vertex of a triangle that intersects the extension of the boundary or the extension of the opposite side of the triangle.
Okay, so I have a question for you.
Yeah.
What do you predict is the total number of hits to that word on the web? I'm going to predict 100,000. Okay, here goes.
That's higher than I would have guessed. I would have guessed like 40,000.
I was going to say 200,000. Then I rounded down. It's 268,000. The top one being Syrian Capital. Okay, I have never heard this word before. Literally never heard it. Who here had heard this word before? Am I just poorly educated?
I had heard it before in meetings about this functionality.
No, doesn't count. Where did it come from?
Seva.
Theory.
Right. So Seva is a mathematician, and so there's a Seva's theorem, and he also worked with these sorts of things. So it's from his name.
Okay, well, I've never heard of it. Is Roger in this meeting? Had Roger ever heard of it?
Roger's not in this meeting currently.
Okay, had Charles ever heard of it?
Yes.
You have a bad data point there for me. Where did you learn about it? Did you learn about it like in high school, or did you learn about it in doing?
Yeah, in high school, long time ago.
Okay.
He went to a much better high school than I did, apparently. I did not hear about this till.
Well, he went to some sort of francophone high school, so
that's true. So that probably has a factor as well. The Phillips on our live stream is saying he's heard of it, but triangles are his life. Okay, look, I just don't think this word is well known. So what is the main thing? This is a line. This is some line related to a triangle, but I don't really understand what some of these other ones are. I don't even understand what the Sevian thing is, so let me just understand that for my education, since I obviously missed this somewhere along the way.
Opposite
web browser going. Yeah, go ahead.
Opposite side and boundary are not Sevians. I forgot I added those in there.
There's a line segment which joins the vertex of a triangle with a point on the opposite side.
Right.
Okay.
So usually,
it's definitely relevant to this.
Right.
Yeah.
Usually, you're given the triangle, a vertex on the triangle, a point not on the triangle, which is the Sevian point, which can be anything, and then you draw the line segment from the vertex through the Sevian point until it terminates at the opposite side of the triangle.
Okay, I get it. So is it essentially is it essentially triangle line through? I mean, is it the analog of circle through?
I don't think so.
No. Okay. All right. Okay. Let's try and name the ones that we can name here, and then let's go back to the other ones. Okay. What is this? What is the medial triangle?
I actually have a picture of so medial triangle is the triangle whose vertices are the midpoints of the sides of the triangle. Okay. Anti-medial triangle is the triangle whose medial triangle is the original triangle. And then triangle is the triangle itself. Triangle,
which we don't exactly have to name.
Right.
I mean, that's a bizarre courtesy.
It was just to have a default, if the specification was not given, return.
And there are many more named triangle constructions that we could support in the future.
Okay. So a named triangle construct. I mean, how many named pentagons are there? Are there named pentagons too? I'm sure there are named quadrilaterals.
Pentagon.
What's that? I'm joking about pentagons, but for quadrilaterals, there surely are lots of named ones.
There are around 20 named ones.
Okay, and of triangles, how many?
Well, I mean, there are named quadrilaterals, but are there named quadrilateral constructions?
Not many.
No, there are not many of these. That's correct.
Okay, so for triangles, this kind of I mean, I'm making up names here which are not good, but modified triangle. That's transformed triangle. Those are all bad.
Derived triangle.
Yeah,
that's better. That's better. It's definitely better.
Although Yeah.
Yeah.
I mean, yeah.
Go ahead.
Oh, I was saying I would like all of these things to start with triangle. But
I would too. Yes, I would too.
I would think, well, triangle construct, I guess, is too...
It's also hard to read because construct could be a verb.
Right. Triangle construction doesn't necessarily have to be a triangle.
Yeah, that seems a bit weird. Okay, but let's keep going with more of these to name and just to understand which ones we have a definite. Okay, so triangle center, I think that there's a bucket of those that seem very reasonable. What is the Symmedian point?
The medium, so that actually is a center. So there are
okay, so all of those,
yeah,
all of those are validly thought of as centers of various kinds.
Yes,
except for the last three, right?
Well, yeah, Syrian endpoint is not, foot is not, midpoint is not, median endpoint is not, an angle bisecting Syrian endpoint is not.
Oh, I didn't realize there was a second line there, but
yeah.
Okay, so those are essentially triangle points of some kind, triangle special points.
Yeah, so those last ones are endpoints of Syrians.
Well, that's lovely, but is triangle point a reasonable name?
I wonder if it should be triangle endpoint. Well, it's not necessarily an end point.
No, because the
point is clearly not.
Right. Well, they are. Well, no, the foot is the endpoint of the altitude. The midpoint is the endpoint of the median. The Symmedian endpoint is the endpoint of the Symmedian, and the angle bisecting Syrian endpoint is.
There's a certain very 19th century character to some of these names.
I don't think we can guarantee that any named points we come up with in the future are going to necessarily be either centers or endpoints.
By the way, when would Mr. Sever or whoever, is that like from the 1600s or something, or is that like or is that like I'm sorry, I'm just doing my little education here. That Giovanni Sever. Okay, I was right. 1647 to 1734. Okay, so it's the same time as the as all those weird things. Not the Gudamanian, that was later. The things, oh gosh, what are those things called where you transform quintics? Michael, you know what I'm talking about? All those weird theorems for transforming quintics to normal.
What's the name?
Titch.
Yeah. I know. Yeah.
Yeah, right. It has another strange name.
Yeah.
Okay.
Chernhaus.
That's right. Chernhaus transformations. Well, I mean, so the Sevian thing, it just seems really weird. I mean, if it's like, okay, are these all versions of altitudes?
Would it not the easiest just classify by return type? So line, infinite line, point, circle, triangle, and then it's also very extensible for the future.
Yeah, I think.
Well,
rather than
triangle,
triangle, meaning just purely structural.
Okay.
Like derived.
They're not variations of altitude.
Right.
Okay.
So something like derived triangle line, although derived triangle would be stupid.
Right.
Okay, so
we take polygon.
Yeah, derived triangle polygon. They're probably all going to be triangles, but
I think that's a hack. I think it's a naming hack. Okay. Okay. So the point here. Okay, let me just understand. Okay, those are infinite lines. So those are going to return an infinite line object.
Right. So usually an angle bisector, in terms of a triangle, most people want the Syrian, which is that line segment, which is why we have angle bisecting Syrian. But we're also introducing just a general head angle bisector, which returns an infinite line. So that was kind of a question of, should angle bisector in terms of triangle data or whatever we call it, should probably return the same type of thing.
But the thing which is super confusing, I mean, some of these things are really like perpendicular bisector. You have that as an actual head here.
Yes.
So this is the perpendicular bisector of what? You've got ABC. So which one is it the perpendicular bisector of?
You would have to say list perpendicular bisector, comma A.
Ugh.
It's
Right.
perpendicular bisector
So
based on opposite.
of these, by default, it assumes the second vertex. So just to be clear, we have a separate head perpendicular bisector that just works on, a line segment or 2 points.
Yes, I understand.
Yeah.
In general, the things that have their own name are a little bit more extensible and not just for triangles.
Yeah.
Fair enough. Sandra on our live stream is suggesting the rather obvious solution of suggesting that.
But once we have this, aren't we then not back at a 2-argument version of triangle data, where first argument is type, second comma name?
Well, yeah, but it's a well, this isn't type. This is some totally weird thing here.
No, and then kind of because the name implies the type, we elide the type.
I still think it's look. I'm not big on this derived thing. If there's a different name,
yeah, I don't think there. I mean, except possibly for the, for the constructions, I don't think that derived is right. Well,
I don't
suppose
either.
it is
I think
for some
triangle
of them.
circle. Look, triangle circle is a nice name for what it is.
But sorry, like, which one do you think is not derived in a reasonable sense of the word?
Area, perimeter, angle measure.
Maybe.
Like certainly something like, altitude is a construction, but area and exterior angle they're not derived. They're just properties.
How about triangle derived circle? I mean, at least means, triangle derived circle, triangle derived line. If you see that in a piece of code, it's not completely obscure what it might be.
Mm-hmm.
I think without the hyphen between triangle and derived, I'm not sure.
Yeah, I think I prefer the derived triangle line.
I don't like putting derived first.
Yeah, I'm perfectly okay with triangle derived. And I like the fact that triangle comes first. It certainly, granted we don't have the literal hyphen, but I don't think that's unique to this name.
Yeah. But let's see whether what the other ones work here. Triangle derived infinite line, that's fine. Okay, triangle derived triangle is very weird.
I think it would be triangle derived polygon. They just happen to all be triangles.
But we might, in theory, say at a hexagon.
From a triangle?
Yeah.
Okay, fine. It's a hack. It's a naming hack, guys, but I think it's an acceptable naming hack.
Right.
Okay, so what else do we have here? We have triangle. What about this thing? Well, triangle derived point is fine, although I have to say I would love to have triangle center if that's what they all are.
A while ago, we did have triangle center, but then they got merged into all this other stuff.
Well, I would argue that triangle center, I don't know how useful triangle center is. How commonly does it occur? I could imagine triangle center.
Of all these things, I think triangle center would probably be the most common.
I think so too.
Because, centroid, circumcenter, orthocenter is very big.
Fine. Well, then, I think we could potentially have triangle center be a separate thing, which is, a special case of triangle derived point. Okay, so the one remaining thing, then we've got triangle derived value. That's a little weird. Because what are those things? Those are scalars, basically.
Right. And again, I'm going to assert that they're not really derived.
Okay, well, maybe it's the wrong name for those ones.
Yeah, that's more of like a triangle calculation.
Yeah, or which is, triangle measurement, triangle. Are they all measurements? Well, they're scalars, so they have to be measurements of some kind.
I was just going to say, if they are scalar, must be a measurement corresponding.
Yeah.
I don't think triangle measurement is terrible for those ones. Triangle measurement, the triangle comma height. That seems consistent with our other use of measurements, for example, image measurements and things like this.
Yep.
All right. Well, I'm liking these. Let me put it.
Very for completeness, we would have infinite half-line, or we
triangle derived infinite half-line.
Well, half-line. We don't need to return any half-line.
I know, but just for completeness. I mean, it really begs for it if you see that list.
I personally think we've gone too far splitting these things up.
So you're right. I mean, I was wondering if you really need line and infinite line.
Maybe not. Why would we need that? I mean, we just return an infinite line if it is an infinite line.
Well, how about triangle construction, triangle measurement, and triangle center? And construction could be various different things.
So what are you proposing that triangle construction would be?
Lines, infinite lines, polygons, circles.
Yeah. That doesn't seem stupid to me. Let's look through that for a second, okay? So that would be something like triangle construction. I don't think that's a construction. I mean, a construction is like, a thing with a ruler and compass that has 6 steps type thing. It's not
the result of the construction. It's not a process.
Right. Which would be triangle construct, which is hopeless because it's got a noun-verb problem, et cetera, et cetera, et cetera. But I don't disagree that having a single thing that represents something that comes out. Okay, what could we do there?
Triangle feature was one suggestion. I'm not sure if it's quite right for this.
It's not really right. I mean, the circumcircle is hardly a feature.
Mm-hmm.
Structure. No, that's not right either.
Triangle structure isn't necessarily wrong.
I think it's hard to read. I think
you saw triangle constructed primitive.
It's not necessarily a primitive.
No, it's a graphics primitive.
Is it graphics? No.
It's a graphics primitive. It's a line, a point.
Triangle constructed?
It's either a scalar or it is a graphics primitive.
Look, of these, triangle construct, which unfortunately gets read as a verb too much. I mean, let's look at what it would look like. It would say triangle construct, and then it would be some triangle. And then it would say something like altitude.
I mean, that also works as a verb, right? Construct the altitude of this triangle.
Yeah, I agree. Not terrible. And then, so then the other functions that we would have are triangle measurement.
Are the ones that return scalars.
Right.
Yes, those are the ones returning scalars. And then just for jollies, we would probably have triangle center.
Right. Well, triangle point, which would be fine in terms of construct because we would not return a point head. We'd only return the coordinates.
Why would we return for the center?
Yes. So that would separate it from the construct because it's not a geometric. It's not a primitive.
I see.
So where would things like foot fall in here? I would be fine with foot and midpoint showing up under triangle construct.
So but remember that they are points then. They are point as in points. Right? They would never be allowed to be just coordinates.
Then that makes things hard for us because we want to say things like A equals the foot of some altitude.
Fine, but then, okay, so look, triangle center, triangle point doesn't seem to me to be a hopeless thing to have in here as well, which would give you your foot. You know, given the triangle, there's the foot of the triangle as XYZ. Right, but triangle
I think it's
construct,
pretty weird to have both center and point.
Right.
But the real confusion is that we have the double meaning of point.
Right. Well, I mean,
explain that to me.
Like the uppercase point could refer to point open close as well as to the pair of coordinates, which we also call a point.
Oh yeah, I forgot this is in 2D.
This is the real trouble, I feel like.
Okay, well, what is, when you say A in geometric scene, when you say A, does it mean a point point, or does it mean an XY?
It means an XY.
Although it does, I mean, inside geometric scene, I do handle point somewhat decently, I think.
But it's more for convenience, not as a matter of.
Well, okay, so the real question, which we were sort of sweeping under the rug here, is what does triangle construct return?
It returns.
And does it matter to you? Because if it's going to return a circle, it has no choice but to return the circle.
Right. So I think it has to return a capital point.
Right. If it's.
I mean, because we are not speaking about subset-like relation, in principle, the code could be smart enough to identify uppercase points with its first argument.
What if we combine triangle center and triangle point into a triangle location?
Well, triangle location.
That doesn't. I'm not keen on that. I think if we're going to do that, we should call it triangle points. No,
not coordinates.
If it returns a capital P point, then we'd have to do things like say point of A equals triangle construct, blah, 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 or we would have to identify capital P points with coordinates.
Well, why aren't we doing that? I think we're going to end up having to do that.
I think it will be fine for the synthetic geometry, but I feel like it will lead to a lot of trouble in Charles's world.
Charles, can you comment on this?
I doubt it is something we have to resolve anyway. So.
No, but my question is, look, to me, if this function has to return a circle symbolic primitive, then there's no way it can return anything other than a point symbolic primitive. It's only for synthetic geometry that we have this idea that variables can be points.
Not really. I think the real problem is much earlier. Assume you have a set of points and you make a line between the points. You can't make line of uppercase point, comma uppercase point. You must take things out.
Maybe we should fix that. Maybe we should fix that, Michael.
It's something we are going to fix anyway. I mean, we have that general problem in geometry. You say, XY element of a list, of a line, or you say point XY element of a line. So it's a general problem. You have to the whole geometry thing we are thinking about, and we probably will have to resolve somehow.
Well, I mean, there's a very simple resolution of the basic thing we just discussed, which is something which I'm surprised doesn't already work, which is just make this work.
But by work, you mean formatting graphics, or you mean by work?
I mean, it could just evaluate to the line of the point coordinates.
I think people will not like this idea.
Why?
Because the geometry things are sometimes in large graphics course with millions of things.
Right.
Now starting adding evaluation rules.
We avoid evaluation rules. I mean,
okay, fine, but fine. Then simply render it the same. Right. And for synthetic geometry, treat it as the same. That will be my thought. I mean, I can't see what this could mean other than the flattened version. Let's look at some other things and let's come back to this. I think
so. It could mean something else. It could mean basically like if you would have a graphics of line xxx line y, and then you have a graphics of the same line plus the points, you would see slightly different endpoints. So it could mean something else. Would be not unnatural.
What? This is like open sets, closed sets
No,
type story?
like points, like just the line would be overall same thickness, but this one could have a little bit thicker endpoints.
Oh, I see.
Right, because lines are really multi-lines. But
so that it's not so obvious that they are really identical.
No, but
Okay.
geometrically they're identical, right? I mean, you're just talking about the rendering.
Yes.
Yes. But Michael's point is, I mean, that it's like, mesh arrow, like in list
Correct.
line plot, is
Exactly.
mesh arrow true?
Yes, exactly.
I think there's a question for Brett, who I'm sure is not here.
No.
To opine on this. So let's take that question to Brett and but I think there will be some solution to what this means. And certainly for purposes of symbolic geometry, I think we can assume this means the same thing as the line with the coordinates. So with that statement, triangle construct, which I'm reading purposefully correctly, so to speak, triangle measurement, how important? Yeah, I mean, to me, these sub pieces of triangles, these points and things, seem like they would be more naturally a separate function. I mean, and definitely the foot is different from. See, the problem with the foot isn't enough, right? I mean, if I'm giving triangle with points A, B, C, the foot is below B, right?
Right, unless
correct?
you. Yes, this would be assumed for the foot below B.
Okay.
And if you wanted the foot below A, you would do list foot, comma A.
Ugh. Why aren't I doing, permute the triangle, CAB?
So in our scene descriptions, we would have to.
Right, because if you wanted to say specify the triangle once, like try equals triangle ABC, and then you want things from different.
and we also had a syntax all. I don't know if that's currently
yeah, all works too. If you
Yeah.
want all of them, you can just put all.
I really hate putting foot and B in a list. I don't see how it could mean anything. I mean, if it's more something like that.
Well, we didn't like using. One reason we didn't like using rules is certain cases you need more than one extra specification, and since rule takes two.
Well, let's enumerate. Where is an example of one where you need more than one specification?
CVN endpoint.
There's CVN. Because for CVN you need the vertex and then you need the CVN point. Right.
I mean, it's almost like we'd be talking about, here, putting in something like vertex, CVN point, that we have to kind of spell it out like this. I mean, I just don't know if these things have a sort of random grab bag of different parameters that they need, it's going to get pretty confusing.
Right. We considered the rule using rule to start with, but we.
What about using an association with the parameters specified in these more obscure cases?
But Stephen, we have this all over the place, right? Where you have a string, and if the string takes parameters, it's list string comma parameters.
I know, we do have it. It's not my favorite feature. Let's look ahead. We're going to come back to these in a minute. Let's look ahead at the other things you want to talk about, because I think we're reasonably close to resolving this.
All right.
I tend to think triangle construct, triangle measurement, and a little bit of extra is probably the right way to go. People okay with that?
Yeah, I think I'm okay with that.
Okay. All right. Let's keep going here.
That was the anti-medial and medial triangle, if you're curious.
Okay. Nested lists versus.
Right. So this is exactly what
we were just.
Well, this is part of what we were talking about.
You'd have to evaluate that or the grid thing. The second thing should expand that.
Okay, what's your point here?
So this is back to kind of the original syntax for triangle data. there's a question of, for instance, for like a Sevian, for an angle bisector, if you wanted the infinite line versus the line segment, should there be just two different string heads, like angle bisector and angle bisecting Sevian like we had? Or should we have a list of separate strings like Sevian line, comma, or like you can change that a little bit.
Yeah, I understand. Okay, so it's like we could have a thing which gives a collection of things, like it is a bisector, and it is a non-infinite thing, and so on.
Right.
I don't like
this has
having
quite a few parameters there. But go ahead.
So I don't like having angle bisecting Sevian and angle bisector. I would rather have just angle bisector, and then maybe you could do list angle bisector, comma line, or comma infinite line. To say what.
Yeah, I would agree with that. But the problem is, by the time we've got all these random parameters here, this is starting to look really, really complicated.
All right.
But, can we go on and just look at? Okay, I get this question. So
that was a question. So midpoint is a new construct. So the question is, should it return pointer coordinates?
I think it should do what all these other things do. If you feed it points, it returns a point. If you feed it coordinates, it returns coordinates.
Whatever the first one is. Whatever A is, probably.
Whatever, yeah, if you really want to deal with the case of the two being different.
And then the other question is, it works on 2 points.
It absolutely should work on a line.
Okay, but the question is,
what does it do on a polyline?
I don't think it should work on a polyline. I don't think that's, well, maybe a polyline, but
it could go different, half the arc distance.
In principle, it could work on an irrectifiable curve, but that'll be hard and it won't be.
Yeah, I understand. It's not a version 1 feature, but midpoint. I mean, what it would do is go a certain distance along the arc length, right?
Right. It would go halfway along the arc length. But
people are going to want generalized midpoints. They're going to want 1/3 of the way. If we give them this, they're going to want 1/3 of the way. Okay, which is an argument to have the first argument be in a list, which I favor anyway.
I was going to ask that.
Okay, I would favor doing this. I would say midpoint of the list, PT1, PT2, because that gives you the opportunity to just go ahead and say midpoint of a line, which is one argument thing.
Right.
It also gives you the opportunity to have a second argument, somewhat obscurely, which is how mid do you want your midpoint, so to speak. Like a quantile, it's like the difference between well, that would be median and a quantile, but
Charles, are you okay with that would kind of order the give an order to the line?
Well, I don't mind any feature as long as we, if it's a geometric feature, we are ready to support it for all the correct primitive.
Right. Hey, I've got a question. This is a very naive question, but there are quantiles, right, for median type stuff. What is the analog? Why isn't there am I being really stupid? For a mean, why isn't there, instead of saying I want halfway through the data, I want 3/4 of the way through the data? Am I being stupid? Is that something totally obvious?
I don't know what that means.
He's asking for the
well, I'm saying that you say
like median is if you have an ordered list of numbers, the median is the middle one. If you want,
it's the halfway through the thing, and that's why the quantiles can be the Q of the way through the thing.
Right.
But in this case, when I'm saying, oh, you can have a midpoint line, but you can have the 3/4 of the way midpoint line.
What does 3/4 mean?
Right, but that's only assuming you have Right. So I guess the
I see.
question.
It's like a distribution. It's like a uniform distribution of points. Within that, 3/4 is with respect to a uniform distribution. You can say, if you've got a line from A to B, it's the the point 3/4 of the way along is well defined.
Well, only if you assume that there's a beginning and an ending.
It assumes an ordering. Like, what if you just had an implicit region in the first argument?
Right.
Then what's your point? I mean, then
what does 3/4 mean?
But you claim midpoint still means something.
Well, because it's a midpoint.
Symmetrical.
Yeah.
Doesn't matter which end you start from.
Okay.
Exactly.
There are some well-known geometry theorems involving find a point 1/3 from A to B.
Okay, so it's a future question whether the midpoint has to be generalized for the second argument. Sandra is pointing out that has to work, which of course is true.
So you for sure.
Wait. What is that?
That's a semicircle.
Oh, sorry, I didn't read it carefully enough.
But what is it? Is it on the circle or is it the center of
gravity on the circle?
Yeah, it's a midpoint on the circle. Just like if it's going to be on a curve, it's the midpoint on the curve. It is half the arc distance.
But what about if the circle is defined as an implicit object, an object which doesn't have a head circle?
Or
an implicit region, a parametric region can be a circle. So what would be the midpoint of those?
Sorry, say that again. You're saying a parametric region that happens to correspond to a circle.
Exactly. So here we are kind of making the relation because the head is a circle, our expression. So it's midpoint of a circle.
Well, of a semicircle. Yeah, I mean, I don't know what it would return if you didn't have the third argument to circle there.
Yeah, what is the midpoint of a full circle? Nothing. Who knows? All right, so look, there's some question about how far the midpoint goes. But the concept of having a midpoint and that its initial arguments should be in a list seems okay to me. Any objections?
No.
And if you feed it points, it returns points. If you feed it symbolic points, it returns symbolic points. If you feed it coordinates, it returns coordinates.
I don't think it can return unless by symbolic points you mean explicit lists.
Right, symbolic.
I don't see how midpoint of A comma B can evaluate.
We needed to not evaluate.
Yeah, I think Stephen meant by symbolic pairs XY.
Yeah, symbolic.
Well, no, what I meant was, but perhaps I'm wrong, if you feed it something like this, what is it doing if you feed it this? Is it returning, mean of x1, y1, x2, y2 and a point?
Yeah, I think that's fine.
Yeah.
Okay.
But point.
I mean, you can remove the list and evaluate it and see what it actually does.
Well, so currently it only accepts coordinates. It does not accept.
Okay. All right. Let's keep going. Perpendicular bisector.
So then this is just a question of.
So angle bisector should obviously be able to take points as well, right? And what does angle bisector return? Does it return a line?
Infinite line.
Okay. But it does that. It actually computes it.
Yes.
Okay. Okay. So one idea for some of these, the cvionation of these lines, that is cookie cuttering them to inside the triangle, which is what you're basically talking about there, of the finite line segment. That seems to be a general operation that comes up in a bunch of places. That is taking an infinite line and chopping it to within the triangle.
That'd be region intersection.
Okay. But is that something that, so is that sufficient to say, that's your definition of, well, fair enough. Okay, should perpendicular bisector take a list of points or a sequence of 2 points?
It sounds like if midpoint's taking a list of points and angle bisector takes a list of points, then perpendicular bisector should probably take.
Right, should take a list of points. But what does it actually return here? So I see. So it's infinite line.
Because a perpendicular bisector also works on a line, and so we clearly wanted to take a list of points now.
Yeah, we clearly do, because it yes.
Yeah.
I mean, but then let me just understand. If I say graphics of line of comma infinite line, why has that infinite line got two coordinates there that aren't?
So it's so infinite line has two argument structures. One is a list of 2 points. The other is a starting point and a vector. So this one, for perpendicular bisector, it has the starting point as the midpoint, and then it computes
I see.
the direction vector.
Okay. But now, okay. So if I wanted to, so what you're telling me is that if I say region intersection of that infinite line with a triangle, let's see, is it like this? No, it's just 1, 1, 1. What the heck does that mean? A two-dimensional empty region? Why is that an empty region? Well, let me make my triangle bigger. My gosh, that's actual math. Wow, that's cool. Does anybody know we can do this?
Yes.
There's a lot more we can do in geometry, actually.
Yes. In fact, there are all sorts of questions about where region intersection fails because you're doing some, bizarre mesh region with some Boolean region, and somewhere it falls down.
Wow. By the way, these are nice examples if you need examples for documentation and things. I mean, it was not obvious to me that stuff like this would work. It's pretty cool. Okay, in any case, okay, so we've agreed on perpendicular bisector. Okay. Subvalues for geometric scene.
So this is, so if you use, I guess it's random instance of geometric scene, you get a scene and then you want to extract things from the scene. For instance, it normally returns something with a geometric scene head that formats as graphics, but if you want just a graphics object, you could use, string graphics. If you request multiple instances of the scene.
How do I do that? I do that with random instance, comma 2 or something?
Yeah.
Okay, that's fine. Just like I can say random word or something, comma 3 or something like that.
So open up those cell groups. See what they have.
Yeah. So if you do that, the head of this is still geometric scene. And if you copy and paste any of these individual scenes, each of their heads is still geometric scene. But by default, it formats as a tab view.
Is that a good idea, as opposed to it being a list?
Well, right, because if it's a list, people are going to think that the head are more likely to think that the head is a list and not geometric scene.
Okay.
So the idea is, if you want a list of these individual things where the head is actually list, you would have this sub-value, and Ian and I were arguing, I would prefer sub-value string lists, he would prefer sub-value string instances.
Well, but graphics gives you the graphics. By the way, you did say at the beginning of this meeting that this extra space here is going to get fixed up, right?
We have to deal with this, yes.
Yeah, we'll deal with it.
Okay.
So yeah, graphics, if it has graphics returns either a just one
single graphic or a list of graphics.
or a list of graphics.
Okay, what does instances return?
So
Yes.
instances. So Ian and I were arguing over what it should return because I think list should be. He thinks instances should return what list returns down here.
What's the difference in what list returns? Well, list is returning individual geometric.
Yes, these have head geometric scene. Graphics has head graphics.
Well, I think that the obvious thing to do would be to say scenes in this case, because this is the case of plural scenes, right?
Right, but tab view will return a tab view. It'll have head tab view, but each individual thing inside the tab view will have head geometric scene.
Wait, what?
You're suggesting yet another subvalue.
Well,
Look at the ref page for all of the.
yeah.
But it's just a subvalue that returns something convenient for you.
Oh,
So
that's
it's
not
big deal.
the default return value. You're
No.
saying. Okay.
It's
Sorry.
just a rewrite.
Right. The default return value is if it's just a single scene, it's head geometric scene.
No, but the default, if you have one scene, if you do find instance, right? It returns you one scene. When you add several of them, the head is tab view.
No, the head it formats as a tab view. The head is still geometric scene.
Yeah, well, I don't understand why you need the subvalue tab view. And if you don't like scene of scenes, why not scene of scene list? And then it's
right. I agree. We don't need tab view, and if we get rid of tab view, then you can do scene list is fine. I don't see why we need tab view because we could just do tab view.
So then fine. So then what we would have is scene of graphics and scene of scene list. And scene of scene list doesn't make any sense if you just have a single scene.
No, it would give a list.
It gives a singleton list.
Yeah.
Right. Yeah, this is good.
Uniformity of stuff.
Because what we had as subvalue tab view would just be tab view of scene list.
That's stupid.
Sorry, what are you saying?
It would really help if you open the ref page for geometric scene.
Yeah, I think not everybody's talking about the same thing anymore.
Right.
Okay.
There where it says getting properties.
We didn't even talk about conclusions and things.
Right.
No.
What is quantities?
So for when you're describing a geometric scene, if you want to say have a scalar quantity rather than a point that is abstract, then the first argument to geometric scene can be a list of two lists. The first list will be the list of abstract points. The second list will be the list of abstract quantities.
Well, I'm sorry, what does possible functions to be used within method include? That's really weird. That's really weird. I've never seen us do that before.
I have not seen this before. Maybe
that seems awfully weird. So just so I understand, if I go back up to my original example here, and I take this creature, and I say conclusions here.
So that'll be, since we didn't run the fine geometric conjectures, there are no conclusions, so just an empty list.
At this point.
Right. So inside the geometric scene,
so if I say find geometric conjectures here.
Did we load the conjecture code? I forget whether this is going to work.
It's loaded, but not guaranteed it will work.
Yeah. Also, I don't know if there are any conjectures in final. I might as well try it.
No.
So it worked and it found no conjectures. So
it didn't find any conjecture.
What would conjectures look like?
So
similar things as the hypotheses.
Right. That'll be something like, ABC equals CDE, right?
Okay. Hey, listen, look, logistics here. We're running out of time. And I think we made some good progress on these. Let's work through this triangle construct, triangle measurement thing. That seems reasonable. I'm a little bit unhappy about this weird sort of pot of different function, parameters and so on that have to be given here. And I've already forgotten no, I haven't, what the Sevian thing is. I think, we're going to need another review of this because we haven't really dug into documentation. I think it's going to lead at least another hour and a half, and very soon. I mean, this functionality is wonderful. Let me ask another question. What is our plan for the Wolfram Alpha integration of this?
We need Alpha running on it, and then we need an interactive importer.
From what? So from drawings?
Yes. No, for yes and no. Not kind of drawings in the sense of a given PDF, but in the sense of interactive.
No, I understand that.
Okay.
I understand that. So, and has there been any interaction with the cloud team about that?
Yes.
And is it promising? Is it hopeless? Is it progress?
Because of other projects taking higher priority right now, a little bit on hold.
Okay. But what do we imagine? We imagine that with geometric drawing there, one will be able to give constraints in the geometric drawing layer, which would do some simple stuff right there, just being able to visualize things. And then as soon as you press go, it will feed it into the engine and actually generate conjectures. Is that the idea?
Pretty much. So we have basically you draw something, and then the drawing gets converted in basically the second argument of a geometric scene, and then we run it and
that's pretty neat.
Similar instances, return conjectures.
That's pretty neat. Okay. And how strong is what we're able to do here? How I mean, if I gave something more industrial, less educational, would it still work with like 100 triangles and things?
100 would be too much. There are limits to this. It does have to be kind of reasonable.
But it does do a couple of non-trivial theorems.
Right. There are some of the more impressive things it does is actually like there are certain constructions where, for a human, it's, describing the scene. There's a very particular way you have to do the construction to find, maybe there's only one instance.
So sorry, asking about constructions. I mean, so like a ruler and compass construction, like, I don't know, Gauss's construction of the, whatever it was. The
17 gone.
Yes, the 17 going. Can we do that?
No.
That's very hard.
Well, I mean, we could say a regular 17. But we
couldn't write down the steps.
Right, yeah, we couldn't write down the steps. We could end up with the regular 17 guy.
Yes, yeah.
Yes.
Explain that. So what would it mean to write down the steps?
Well, the steps is Gauss's a description of how you use a ruler and compass to get a regular 17.
Yeah, but I don't quite understand what a construction is in terms of these, because these are more or less assertions. I mean, this is like Euclidean assertions of things.
Okay, when I said a construction, I meant the actual construct. Let me go back to the beginning and rephrase this. There are, describing a scene, there are some instances where, up to translations, rotations, whatever, there's only one scene that satisfies a given set of constraints and is apparently difficult for human mathematicians to come up with that.
Yeah, I get it. Right.
But the scene drawer has apparently been able to come up with those scenes on its own.
Okay, fine. But I'm asking a different question.
Yeah.
Okay, so I'm trying to understand when somebody says I'm doing a construction of the 17 God.
Yeah, I think the difference is the following. Right now, this second argument of geometric scene is a little bit like solve. You can give something that's kind of non-locally refers to each other, and the first variable can be 10 equations later. Constructions would be if the nth plus one object contains only variables from the first n steps.
So you mean it's like replace as opposed to solve?
It's going forward, kind of use what you have and explicitly tell you what to do next.
So question, I mean, in the case of, I mean, that's what we do with replace with /dot, for example, which solve, whereas solve is able to kind of look ahead to a bunch of those things. So I get that. But in the primitives that we have here, are they adequate to describe a construction? Like we say, take the bisector of this and this, do this, do this, do this. How would it look like if you were doing construction?
You'd have to say like C equals angle bisector or whatever.
Okay, but then the result of all of that would be, if you unravel that, it will be some expression like one of the ones that we have here, won't it?
Right, but it's kind of given the construction make this. The hard thing is kind of write a non-local one basically in triangular form, so to speak.
Right, but I mean, in a sense, the construction is going to have a unique result.
Yeah.
In this case.
Correct. Now, yes and no. Like a construction does not have to be unique. Like pick a first point, pick a second point.
Fair enough.
There's nothing unique.
Okay, well but when you say make a construction, there is an expression like the 17 gone. The result of doing that construction is an expression, isn't it? In terms of whatever initial point you take, it's going to be some expression involving bisectors of this and circles around that and so on, relative to the initial point you take.
I mean, maybe I'm not entirely following, but I mean, a construction is a sequence of steps, right? So this is going to be, it's not the final result, right? So it's going to be a list of things.
No,
right?
I'm talking about the final result that you have constructed. I'm saying evaluate the C equals blah, blah, blahs, and then the result of all of that is going to be this combined thing that you create.
Yeah.
And that combined thing, I would claim, up to some trivial sort of degeneracies, will end up being, here's a 17 gone or something, won't it?
Yes.
Okay, so ideally, if like we have a graph and all the steps has been mentioned as like a geometric assertion, then run find geometric conjecture, it should return like something like geometric assertion regular polygon with 17 points in it.
I see.
But I thought, if I correctly understood, Stephen was wondering if we can kind of reverse the thing and give something and give a sequence of consecutive steps that leads to the object.
Well, that was a different thing. I was simply asking, what does it even mean if we want to make computable Gauss's construction of the 17 gone? What would that mean?
That has no meaning in our world, because the special thing in the Gaussian construction is that you only can take square roots and not any cube root ever. But because we use numerical techniques, we have no notion of doing only operation equivalent mathematically to taking a square root.
Okay, so I mean, if you're saying solve for, given this object, the thing you were just mentioning, given this object, solve for the sequence of steps to get to that object using ruler and compass. I understand we haven't built that at this point. No. Does anybody worry about that anymore? I mean, back in the day, people, 50, 100 years ago, people were quite keen on, given this thing constructed with ruler and compass. Does anybody care about that anymore?
Well, we have the functionality to do ruler, compass, and computer, but it's always a one-step process.
People care about constructive geometry generally, but I don't know necessarily straight.
But ruler and compass.
I mean, depends on your. I think it depends on your definition of care, right? I mean, people still teach that when they're, teaching Euclid.
They teach how to, given this object, you make a construction in this way.
I don't ever remember really learning that in a class where
very few.
Well, I certainly did in my 8th grade geometry class, but certainly, did you ever take like a college, Euclidean geometry class? Because if you're reading, there are certainly classes where they, actually teach Euclid, and if you're reading Euclid, then you have to be able to do this to follow his proofs.
I see.
Right. I don't.
Okay. Anyway, we should.
The more interesting thing in this direction, not the things that you can't do with ruler and compass.
Well, yes.
Right.
But that's a ruler compass cue, which we'll get to one day, which is kind of the question of whether things can be done with quadratic,
Exactly.
things or not.
Yeah.
All right. Okay, let's wrap this meeting up. We need to continue.
So we should go ahead and implement this new named function.
Yes, I think so.
And you can send me the notebook?
Sure. That's what we get for not having a project manager. We all just have to send these back and forth.
Yeah, but we save a lot of time of
edit.
people. Nobody has to waste their project.
So I don't know if you heard, but Carla just announced her presence. So if you put it someplace, she can get to it.
She has it. It's under geometry in the ILD folders. But
Okay, I'll send that out.
I sent it to Michael.
Okay.
All right. And people on the live stream, by the way, we are about to start another meeting about general Wolfram language updates. So see you there. Talk to you all soon.
Okay.
Bye.
Bye.
Bye.